right, students, now for your Unit 1, Section 2 notes, Part B. Now we're going to look at the examples with scientific notation. So example 1 says express 45 million in scientific notation. Well, what we really want to do is we want to think of, first of all, a number between 1 and 10 that's going to use all of our significant figures. So currently we just have these two significant figures. So our number between 1 and 10 is 4.5. And that's using all of our significant figures. And 4.5 times 10, we want to know how many times we have to multiply by 10 so that the equivalent is the same. We want these things to be equal. So if we think about if we just started with 4.5 times 10, well, that would give us 45. If we multiplied it by another 10, we'd get 450. Another 10 would be 4,500. And I want to keep multiplying by 10, so I'm counting my numbers of 10. So here's 1 10, 2, 3, 4, 5, 6, 7 until I get the same match. So let's look at this. So they match. That's great. And so I had to multiply by 7 10s. Well, of course I could just keep writing out all these 10s, but that's going to be a lot to get down to 7. So I'm going to use my scientific notation. I'm going to use my powers of exponents to help me. So I'm going to multiply by 10 to the 7th power. All right, so that's going into scientific notation or into standard form. Well, if I have already standard form and I want to write as a decimal number, that means I'm going to expand this out. As I can't remember if we've looked at this or not. 10 times 10 to the negative 8th. Well, let's test this in our calculator and see what happens. Clear this out. So we had 3.17 times 10 raised to the negative, not the minus, the negative 8th power. If I look at this, I still get my same scientific notation. So I don't really know what's happening. So let's make a smaller number to help us figure it out. 3.17, let's just do times 10 to the negative 1. So now if I say to the negative 1, this made my number smaller. So instead of multiplying by 10, it's like I divided by 10. Let's test that. 3.17 divided by 10, yep, gave me the same number. So if I repeated that, if I divided by 10 again, that's 0.0317. So now I've taken this decimal, moved it over twice. Let's test that that's the same thing. So that's 3.17 times 10 to the negative 2 raised to the negative 2. And it is the same thing. So this leads me to believe when I multiplied by 10 to the negative 2, I took my decimal place from here and moved it over 2 places. Well, that implies to me that when I say negative 8, I'm going to take my decimal and I'm going to move it over 8 places. So 3.17, I'm taking my decimal and I'm going to move it to the left by 8 places. So we're going to move the decimal left 8. So that means 1, 2, 3, 4, 5, 6, 7 zeros, and then the 317. Because I would have moved it effectively 8 places then. It started here, so 1, 2, 3, 4, 5, 6, 7, 8 places over to its final spot. Notice here I can think of it the opposite way. This is telling me move 7 spaces to the right because it's positive. So I started at 4.5, 1, 2, 3, 4, 5, 6, 7 places to the right when it's positive. So negative is telling me to the left, positive is telling me to the right. And those are your examples for scientific notation. Of course, we will practice this more in class, and I will see you there.